Good morning to everyone. I am P.M.Arthi, System Computer in the Department of Artificial Intelligence and Data Science in Tech Architect after Secondary Training College. Today we will discuss the very important topic in Ahoop's concept is inheritance. Inheritance, one of the four pillars of OOPS, along with encapsulation, polymorphism, and abstraction. In this session, we will cover what inheritance is, why we use it, its different types, examples in the some practical programs in what is inheritance. Inheritance is an important pillar of OOPS. Inheritance is the process of creating new class from existing class. It is the mechanism in Java by which one class is allow the inherit the features of other classes. Important terms: subclass, child class. Subclass is a class which inherit the other class properties. It also called as derived class, extended class, or child class. Superclass or parent class. Superclass is a class that give the properties to the subclass. It called as derived parent class. Inheritance create new classes from existing class. The existing class is called as superclass or parent class. A new class is called as subclass or child class. The subclass automatically inherit all fields and methods from the parent, which save us from duplicate code. We can also add new features in a subclass or modify the existing one. For example, think about the general vehicle class. A car or bike class is inherit properties like speed and fuel capacity, then add its own specific features. Two main reasons we use inheritance are code reusability and method overriding. Code reusability is reuse the existing logic instance of rewriting. Method overriding is that subclasses can redefine parent methods which lead to runtime polymorphism. Example, a parent class animal has method make sound. Dog and cat subclasses override it differently. In this polymorphism in action achieved via inheritance. The important terms reusability, as the name specifies, reusability is the mechanism which facilitates you to reuse the fields and the methods to the existing class. When you create a new class, you can use the same fields and the methods already defined in previous classes. Why we use inheritance? For method overriding, so running polymorphism can be achieved, or code reusability. Types of inheritance. Single inheritance. In single inheritance, subclasses inherit the features of one superclass. An image below a class A serves a basic class or derived class B. So class B derive the properties from class A. Next, multiple inheritance. In multiple inheritance, one class can have more one subclasses and inherit the features from all parents. Java does not support multiple inheritance with classes. In Java, we can achieve multiple inheritance only through interfaces. In image below, class C is derived from inheritance A and B. In single inheritance, one subclass inherit from one superclass. For example, class dog extends animal. It is the most common form. Multiple inheritance. Java does not allow the class extend for more than one classes, but interfaces class C implement A and B. Then multi-level inheritance. In multi-level inheritance, a derived class will be inherited. The base class as well as the derived class also act as the base class to the another derived class. In below image, a class A is a base class of derived class B, which terms serves a base class of the derived class C. Here there is the three classes present here A, B, C. A chain of inheritance, for example, grandfather, father, and son. In Java, class C extends B, class B extends A. Hierarchical inheritance. In hierarchical inheritance, one class serves a superclass or base class of more than one subclass. In below image, class A serves as a base class for derived class B, C, and D. One parent with many children. For example, animal superclass, dog, cat, horse, or subclasses. Last one is hybrid inheritance through interfaces. It is mix of two or more above types of inheritance. Since Java does not support multiple inheritance with classes, the hybrid inheritance is also not possible with classes. In Java, we can achieve hybrid inheritance only through interfaces. A combination of two or more types achieved only using in Java, interface in Java. We have seen different forms, but how does interface inheritance compare to another reusable approach and the comparisons? Here the examples of types of inheritance. Single inheritance, public class A is the base class, public class B is the derived class. The base derived class B extends A. Next one is multi-level inheritance. In public class A is a base class. Public class B is a derived class of A. It extends class A. Public class C is a derived class of B. It extends class B. Hierarchical inheritance. In hierarchical inheritance, base class is class A. The derived classes are class B and class C. Class B extends class A and class C extends class A. Multiple inheritance. In multiple inheritance, we don't support the classes, we use only the interfaces. Inheritance versus composition. Inheritance is a kind of relation. When a class is derived from another class, the object is an object of another class. We use the key extends. For example, a teacher is an employee, a car is a vehicle, orange is a fruit, a surgeon is a doctor, a cat is an animal. Composition. Composition has a relationship. It is also used for code reusability in Java. In Java, a hasher relationship is simply mean that an instance of one class has a reference to an instance of another class or another instance of same class. For example, a car has an engine, a dog has a tail, and so on. In Java, there is no such a keyword that important to has a relation, but we mostly use a keyword important it has a relation in Java. Form of inheritance. Inheritance is used in a way of way and for a variety of different purposes. Inheritance for specialization, inheritance for specification, construction, extension, limitation, and combination. One or more of these forms may occur in a single cases. Specialization. Child is a subtype. For example, Alco card extends card specification. Parent only specifies child implement. Parent only specifies child implements. For example, interface like action listener. Construction. Child reviews the parent behavior but not subtype. For example, create a set from list. Create a set from list. Extensions. Child adds new features. For example, colored window extends window. Limitation. Child restricts parent behavior. For example, stack from list. Combination. Multiple inheritance versus interfaces. Inheritance for specialization. By far the most common form of inheritance is for specialization. Always create a subtypes. Child class is specialized for the parent class. Principle of subsidiary holds. The example is a Java hierarchy of graphical components in AWT components, label, button, text component, area text field, checkbox, and the scroll box. Inheritance for specification. The next most common form of inheritance involves specification. The parent class specifies some behavior but does not implement the behavior. Child class implements the behavior, similar to Java interface or abstract class. When parent class does not implement actual behavior but merely defers the behavior that will be implemented in child classes. Example, Java 1.1 event listener, action listener, mouse listener, and so on specifies the behavior but must be subclassed. Inheritance for construction. The parent class is used only for its behavior. The child class has no relation to the parent. Child modify them. Argument or name of the methods. An example might be subclassing the idea of a set of form on existing list class. Child class is not more specified form of parent class. No supplementaries. Inheritance for extension. The child class generates the extends the parent class by providing more functionality in some sense, opportunity of subclasses or specification. The child class does not change anything inherited from the parent class. It simply adds new features often used when we can't modify existing base parent class. Example, color the window inherit from window, add additional data field, override window display methods. Inheritance for limitation. The child class limits some of the behavior of parent class. For example, you have existing list of data types and you want a stack. Inherit from list but override the method that allow the access to element other than top. So the product error. Inheritance for limitations occurs when the behavior of subclasses is smaller or more restrictive than the behavior of its parent class. The child class limits some of the behavior of the parent class. For example, you have an existing list of data type and you want a stack. inherit from list, but override the method that allows the access to element other than the top. So the procedure error will be occur. Inheritance for combination. This type of inheritance is known as a multiple inheritance in object-oriented programming. Although the Java does not permit a subclasses to be formed an inheritance from more than one parent class, several approximations to the accept are possible. Example of this type of whole class defined as class 4 extends ball implement pinball target open those form of inheritance specialization. A child class is a special case of parent class. In other words, the child class is a subtype of parent class. Example, all code path is a path specification. The parent class defines the behavior that implemented in the child class, but not the parent class construction. The child class makes use of behavior by the parent class, but is not a subtype of parent class. For example, format a set of existing list classes. Generation, the child class modifies or overrides some of the methods of parent class. Extension, the child class adds new functionality to a parent class but does not change any inherited behavior. For example, colored window inherits from window. Limitation, the child class restricts the use of some of the behavior inherited from the parent class. For example, you have an existing list of data type and you want a starting combination. The child class inherits features from more than one parent class. In this multiple inheritance, member access rules, which visibility modifier determine which class members are achievable to which do not. Members, variable or methods declared in public visibility are accessible, and those that private visibility are not. Problem, how to make class instance variable visible only to its subclasses. Solution, Java provides three visibility modifiers that helps in inheritance situations. Protected access modifiers control the classes can use public, can be accessed from outside of a class definition. Protected can be accessed only within the class definition in which it appears. Within other classes in the same package or within different definition of subclasses. Private can accessed only within the class definition in which it appears. Default access, if features accessible from inside the current Java package. Public accessible everywhere, private only inside the same class. Protected access to the subclass. Default accessible within the same package. For inheritance, protected is very important. It allows subclasses to use parent data which still keeps it hidden to other classes. Example for single inheritance. In calculator class has add and subtract methods, and my class extends the calculator, adds multiple and divide. We do not rewrite and add and sub. We simply reuse them in this code reusability in action. The data members of calculator is number 1 and number 2. Methods are constructors, add and subtract. My calculator methods are constructor, multiple and divide. Here the my class calculator use the add and subtract method from calculator class. Here the code of single inheritance class calculator contain the variables double number 1 and number 2. The calculator contain the constructor calculate of double n1 double n2. Here number 1 value is changed into n1 and n2. Next add method to add the num1 and num2, print the result to the screen. And the sub method used to subtract the num1 and num2. Then the derived class my class to extend the my calculator extends the calculator. Here my calculator constructor is double my calculator of double n1 double n2. Here call the super constructor super constructor super of n1 comma n2. Then perform the multiplication operation using num1 and num2 and division operation using m1 and m2. Here main calculator is a main method. Here using the public static void main is a main method. My calculator to create a cal object. Using the cal object we call the addition add method, subtract sub method, multiple method and the division method. Add and sub are in the calculator class. We use the object to call the methods and multiple divide in the my calculator class. We directly access the these two methods. We inherit the add and the subtract method. Uses of super key. Super key is used to access the members of superclass within the sub or child class. Super key is a keyword used to refer hidden variables of superclass from subclass. Super.a equal to a used to call the constructor of a superclass from the constructor or subclass, which should be first statement. Super of a comma b, it refers the constructor from the superclass. It is used to call the superclass method from the subclass method to avoid redundancy of the code. In super dot add number of a comma b is the method of superclass, the same name present in the subclass. That's why we call the using the super keyword to call the method. The super keyword is used in inheritance for three main reasons: to call parent variables when subclass hides them, to call parent constructor for child constructors, to call parent methods for child methods. Here the example for super keyword. Why is the super need to access the superclass members? When subclass declare the variable or method within the same name and the type of its superclass. Here class A contains the variable I equal to 1. Class B extends class A. Again class int I contains the value 2. Here we have to print the I value. We get the value 2. If we want to print the value One, we have the we apply the super keyword in here, super.I, then we get the value 1. Example program for hybrid inheritance. Implement following class hierarchy. Use the specific data for each of the classes. Each of those classes should have overridden methods, get and show, to get the data from the user and display the data respectively. Use keyword super to access super member with the child class. Write a test program to create instance of teachers and professor, get data of this, we display their data. Here in the diagram, we we have more than one inheritance class combined together. In person and the bond class is a single inheritance. Person, teacher, and the professor is the multi-level inheritance. And then education, teacher, person is also a multi-level inheritance. Hybrid inheritance, more than one inheritance types combine and give the given values. For example, program of hybrid inheritance. A class person is a base class. Again, the class education contains school name, degree, contains a method, show, get. The person contains the variables, name, age, and the method, show, get. Here, teacher class extends the properties of person. Form class extends the properties of person, and the professor class extends the properties of teacher. Here we use the super keyword to call the show method, the super keyword to call the get method, and then in the professor class we have to use the super keyword to call the get method and the super keyword to call the show method. In a multi-level inheritance box class is the base class, and the box weight is a subclass. It derives the properties from box class, and the segment class is the subclass of box weight class. In a data members of box class are length, weight, height. Methods are constructor, show, get, volume. Weight class data members are weight. Methods are constructor, show, get. Shipment class data method members are cost. Methods are constructors, show, and get. Example for multi-level inheritance. Here, box class. Box class is the base class. It contains the double variable length, weight, height, and then box class contains 3 constructors. One is non-variable argument constructor, 3 argument constructor, and 1 argument constructor. And we also have here methods, volume, show, get. From the previous slide, the box weight method class inherit the properties of box class. Here the variables are weight, constructor are box weight, and 3 argument constructor, 1, 2, 3, 4 argument constructor and 2 argument constructor. Show method, get method. The shipment class, it inherit the properties from box weight. It variables are cost. Constructor is 1 argument constructor, 0 argument constructor, 5 argument constructor, and 3 argument constructor. We'll call the super keyword to call the constructor non-argument constructor, 4 argument constructor, and 2 argument constructor. Using the super keyword to call the weight box show method to shipment method. We have to conclude that inheritance is one of the most powerful features of Java and Eclipse. It helps us reuse code, achieve polymorphism, and build class inheritance. Java supports single, multi-level, hierarchical, and multiple hybrid throw interfaces. We saw examples with calculator, person, box, real-world use of GUI, and explanations. Thank you.